Let's take a look at the next example. This is example 9. We want to solve the equation sine x times cosine x equals to 1/2 for 0 less than or equal to x less than 2 pi. This is another trigonometric equation where we want to use an identity, but it's not quite obvious in the beginning exactly what we should want to try here. First of all, we do have a product, sine x times cosine of x, but even if we brought the 1/2 to the other side, that wouldn't be something that would be able to be factored as we've seen in the past. But if you think about some of the identities that we've encountered up to this point, we have seen a situation where we have a formula that has a sine times the cosine, and that formula was for the sine of 2 theta. The sine of 2 theta, if you remember, was sine theta times cosine theta times 2. So if I look at the left-hand side of this equation, if I just had a multiplication by 2, then we would be able to use a double angle identity, and that would kind of condense the two trig functions into just one, which would be beneficial to us. So let's go ahead and multiply both sides of this equation by 2 so that the left-hand side looks like our formula for the sine of 2x. This is going to be the sine of 2x is equal to 1/2 times 2 would be 1. So we're trying to solve for where is the sine of some angle equal to 1. And again, going back to our unit circle, that would be the quadrantal angle pi over 2, or any integer multiple of that, plus 2 pi n, would be the solutions. So that's what 2x would have to equal. So if 2x is equal to pi over 2 plus 2 pi n, then that would be a solution. And then we can solve this equation for x by simply multiplying both sides by 1/2, or if you prefer, just dividing by 2. It's equivalent. And we get the following. The 1/2 and the 2 cancel, so we get x equals, distributing the 1/2 through, we get pi over 4 plus 2 pi n times 1/2 will just be pi n. So this would be all of the solutions, but we're particularly asked for the solutions between 0 and 2 pi. Now for the integer n, if n would be something like -1, -2, -3, etc., those would produce negative values for x, which wouldn't work because x has to be between 0 and 2 pi. If n is equal to 0 though, then that would produce the solution x equals to pi over 4. That one would work. If n is equal to 1, then x is going to be pi over 4 plus pi, which would be 5 pi over 4. That also works. Now, if n is equal to 2, then we would get x equals pi over 4 plus 2 pi, and that's already going to be too much. This is 2 pi plus an additional pi over 4, which would be more than the 2 pi. So for any n 2 or more, those wouldn't work. So we get just these two solutions. X equals pi over 4 and x equals 5 pi over 4. We'll take a look at one more equation that involves an identity, and this is one of the more subtle ones. And this is a technique that if you can avoid it, you don't want to do necessarily, but if you kind of get stuck, and in particular when this really kind of shines, this next method, is when you have a trigonometric equation where you have a sine of x to the first power, a cosine of x to the first power as different terms. Here we are asked to solve for where sine x minus cosine of x is equal to 1. It's not a trig equation. There's no common factors. We do have two different trig functions. So when we look at it, and there's no obvious identity either, by the way. So there's nothing that would immediately pop out as hey, let's try this kind of thing. But sometimes something that will be effective is, especially in this kind of format, let's try and square both sides. And the rationale behind that is, even though there's no direct relationship between sine and cosine, we do have relationships between their squares via the Pythagorean identities. So maybe if we could square both sides, we can maybe incorporate some of those Pythagorean identities. So let's try that. we have sine x minus cosine of x. We're going to square the left-hand side, and we're also going to square the right-hand side. 1 squared is 1. On the left-hand side, if I want to do sine x minus cosine of x and square it, that's a binomial times a binomial. So you'd have to use the distributive property, or some of you like to call it FOIL. But what we're going to end up with is this. We're going to get sine squared of x. The middle term will be a negative sine cosine x and another negative sine cosine of x, which will be negative 2 sine x cosine x. Negative cosine x times negative cosine x will be a positive cos squared of x equals to 1. Okay, so we've done that. We look at it, we say, well, how has that made things any easier? And it kind of has, because if you look at these two terms right here, we have a positive sine squared and a positive cosine squared, and we know from our Pythagorean identity that those two things equal to 1. So we have negative 2 sine of x cosine of x plus 1 equals to 1. I can now subtract 1 from both sides to get negative 2 sine x cosine of x is equal to 0. I can divide by negative 1 to both sides to get rid of the negative sign, and we get negative 2 sine x cosine of x equals to 0. Well, this thing here, 2 sine x cosine x, we just saw that a moment ago, but that's going to be the sine of 2x. So what we have is the sine of 2x equals to 0. And if I just kind of, actually can't cheat from above, but if the sine of 2x is equal to 0, when is the sine going to be 0 between 0 and 2 pi? Well, the sine is 0 here and here. So that means that 2x would have to be either equal to 0 plus 2 pi n, or 2x would have to be equal to pi plus 2 pi n. Go ahead and solve each of these for x. Divide by 2. We get x is going to be equal to pi n. Here, divide both sides by 2. We get x equals pi over 2 plus pi n. For all of the solutions between 0 and 2 pi, for the first one, if n is equal to 0, we get x equals to 0. And if n is equal to 1, then we get x is equal to pi. Notice that n can't be negative, because if n is negative, then that x value would immediately be negative, and we need to be between 0 and 2 pi. And then once n exceeds 2, then we get 2 pi, and it's supposed to be strictly less than 2 pi. So we get two solutions here. If we come down here, again, n is not going to be allowed to be negative, because that would produce negative values of x, and our x is supposed to be greater than or equal to 0. If n is 0, though, we get one solution would be x equals pi over 2. When n is equal to 1, we get pi over 2 plus pi, which would be 3 pi over 2. That works. And now if n is equal to 2, then you would have 2 pi plus pi over 2, which would exceed 2 pi, so that would not work. So we get two solutions here as well. X equals pi over 2 and 3 pi over 2. So 4 solutions altogether: 0, pi, pi over 2, and 3 pi over 2.